Hi, y'all. It is probably April 1st, Wednesday. You're working on your notes, so let's see how this goes. I guess it would help if you could see your notes. There you go. So we're going to look at how we can count really fast today. All right. Suppose you need a password for a computer. The first character must be A or B. The second must be a 1, a 2, or a 3, and the third must be an X, a Y, or a Z. How many codes can you make? Now, in our last chapter, we did what we're going to do today, which is drawing a tree diagram, and we're going to talk about the fact that that's really not efficient, because if I gave you all 10 digits and all 26 letters, you'd be here all day making a tree diagram. So we're going to see if we can find a faster way to do this. So, but I want you to see, we're going to work out a small one just so you get the idea of what our arithmetic is going to do for us. So the first character is A or B. That's the restriction on my password. The second must be a 1 or a 2. So I can pick my first one, then a 1 or a 2, 1 or 2. And then the third must be X, Y, or Z. So my third one is X, Y, or Z. You can see if you're like me and you write big, this is not easy. Okay, now I hope you realize that this is not practical. If I were to give you 26 letters followed by 10 digits followed by 26 letters, and what if we had more than 3 words in our password? You can start to see that this is not efficient. There's got to be a better way. Let's count up how many ways though. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 passwords here. Right? Now, this was what we did last unit because we wanted a visual conceptually. This helps us understand how we're picking. But is this practical if we want to use all letters and digits? No. Absolutely not. So there's a better way to count? Of course there is. So this chapter, we're really going to get into fast arithmetic instead of this crazy drawing everything out. So what's our better way? Well, we had 2 ways to draw the first one. The second one, we had 2 ways to do that. And on the third one, we had 3 ways, X, Y, or Z. You know, we had X, Y, Z. Here we had 1 or 2. And here we had A or B. So instead of drawing out this long tree diagram, all we have to do is multiply how many ways we have to get each one. And 2 times 2 is 4 times 3 equals 12. Notice the same. This makes me happy. Very big concept. I want you to remember this. This has a very special name. This is called the fundamental counting principle. Very important in statistics. This is a big thing for you to know. If I say use the fundamental counting principle, you just multiply the number of choices for each spot, okay? Got it? Remember that word. As you can see, a good problem for us. Here's a problem I have for you to do today, a fun problem. We don't care about a password. But let's say I was sending you to Starbucks. What if I went to Starbucks and I'm going to tell you what you can order. You get to order a coffee and you can choose any kind of coffee you want. And I'm going to let you choose 3 additions to it. I don't even know what you would call these. You can add caramel or you can get a macchiato, whatever stuff you like to get. So if I were to send you to Starbucks and tell you that you can order coffee that's got 3 other things in it, how many combinations of drinks could you order? Well, you're going to have to look this up. I don't know how many types of coffee Starbucks has, and I don't know what all their additions are. So there's a fun thing for you to look up. And if you were going to do this problem, you should do this problem. Bonus points, right? Even though I don't know if we're getting grades. So it's kind of the honor system bonus points. But if you were to do that, you already know right here that this old antiquated method would be very cumbersome because Starbucks has a lot of coffee. So I'm anxious to see if you figure out how many ways we could make a cup of coffee with coffee and 3 other things, you know, whipped cream, caramel, and sugar, or whatever you want to add to it. Okay, so try that for fun. We're going to do a couple of examples together and then we'll be done. Again, this is April 1 notes. If you're taking them on April 1st, you might be the 2nd, I don't know. And this is no joke, by the way, April Fools, it is not. So the fundamental counting principle, that's what we just learned, okay? Big deal, we just have to multiply. So if 3 events can occur in M, N, and P ways, then the number of ways that all 3 events can occur is M times N times P, okay? A way you might see that written in a book is, well, no, I don't want to bring that up right now. Okay, example, you are framing a picture. The frame is available in 12 different styles. So that's 12 styles. Each style is available in 55 colors. So right away, you know you don't want to make a tree diagram. And 11 shades. I don't know what that means, light blue, dark blue. Okay, how many different ways can you frame a picture? This is very easy. It is simply 12 times 15 times 11 equals 7,260 ways. Okay, fundamental counting principle. Second, the standard configuration of a Texas license plate is 1 letter followed by 2 digits followed by 3 letters. How many different license plate are possible if letters can be repeated? That means they're independent. If you choose 2, you can choose 2 again. If you choose J, you can choose J again. Versus if they're independent, meaning if you use the letter 4, that letter's gone, you can no longer use it. So let's look. What does it say? 1 letter. So I'm going to write down what we need. This works better for me. A letter followed by 2 digits. So I'm going to say digit, digit, followed by 3 letters. Letter, letter, letter. And we're going to do it again dependently. So I'm just going to use an L for letter. So letter, digit, digit, letter, letter, letter. Let's see how these differ. Okay, for my first letter, it doesn't say any restrictions, like you can't start with A or B or whatever. So for the first letter, there's 26 ways. For the first digit, now remember, in our base 10 system, there are 10 digits, right? The digits we have, just in case that doesn't make sense, are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. I'm not going to write a 10 down because a 10 just uses a 1 and a 0. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits in our system. So that's 10 times 10 times a letter, 26, 26, and 26. As you can see, you would not want to do a tree diagram with this. It would be huge. So if you multiply those all out, you're going to get a big number. So 45,697,600 different plates. See, it doesn't sound like a lot, but we can definitely have enough, right? Now, if it's dependent and we say letters cannot be repeated or digits, for the first one, we have 26 letters. For the first digit, we still have 10. Now, the second digit, we've used up a number, so there's only 9. Now, for the second letter, we only have 25 left to pick from because we used one. And then we have 24 because we picked one more, and then 23. So now we're going to multiply those out. And if you multiply those out, we're going to get 32, 292. So that's 32,292,000 different plates. Okay, so that's it for today. You now want to go and do pages 17 and 18 in your packet. That's the homework that goes with this. And I will see you later. Y'all have a great day.